Hey everyone, welcome to Cracking Drupal, my presentation for DrupalCon Global 2020. So let's dive right into it. To start out, just a brief summary of what security is, a sort of framework. Then the meat of the talk will be the top 10 types of web application security vulnerabilities, which you should know basically at the back of your hand. Then briefly talk about some best practices in terms of Drupal and security, and a little bit about responsible disclosure. A couple facts about me if you're wondering why I'm qualified to give this talk. Just framework for what security is in terms of data and web applications. Good framework is the CIA Triad: Confidentiality, Integrity, and Availability. So this kind of model, thinking about those three components, is a way to structure your thinking about security policies and practices. These are the three critical elements of security. If you are lacking any one of those three, your data or your web application is actually not secure. I'm not going to go into detail on this, but you should come back and think about each of those three elements and what it means in terms of why that's important for security. There's also strategies, sort of building off that, for implementing security. So principles to keep in mind, again, this is a brief summary. Trust, you need to think about who can do what. A really important principle that you should apply everywhere in your digital life is the principle of least privilege, meaning that you should only grant enough permission for users to do the tasks that they're required by their job or role. Of course, defense in depth, meaning you shouldn't rely on just one layer of protection or backups or anything else. And a point that we will come back to many times in this talk, in fact, is software updates. Ruling out known exploits in Drupal, in PHP, in your operating system, in your browser, et cetera, et cetera, et cetera. Software updates actually turn out to be one of the most important security strategies you can implement. And it's actually not as easy as it sounds. You really need to budget time to keep things up to date. Okay, so the main part of this talk is the OWASP top 10. So OWASP is the Open Web Application Security Project. This is a kind of an open source project. They do surveys, discover the most critical security risks that people are experiencing out in the wild. They do assessments of those. They update them every few years. Important to note, they order them in the top 10 by impact, not by frequency. So OWASP top 10 number 1 is the vulnerability that has the highest impact if it occurs to you. It's something that people are experiencing, but it's not necessarily the most common vulnerability. So they have a website, of course. You can go there, look for more information on this project and more in-depth details on the OWASP top 10. And they also have on their website lots of great learning resources and tools that you can use to potentially test your site, to learn more about how to mitigate these vulnerabilities. So I recommend you spend some time on their website. And with that, let's dive into it. So the OWASP top 10, here it is. Number 1, injection, most severe. 2, broken authentication. 3, sensitive data exposure. 4, XML external entities. 5, broken access control. 6, security misconfiguration. 7, cross-site scripting. 8, insecure deserialization. 9, using components within vulnerabilities. And 10, insufficient logging and monitoring. Okay, so I'm going to go through each one of these, give you a little information about what it means, why it is a vulnerability, and maybe even give you a little tidbit of code in the Drupal context or PHP context that shows you what such a vulnerability might look like. Okay, so the vulnerability with the highest impact, OWASP top 10, number 1, is injection. And what that means is code injection, such as SQL injection or remote code execution, meaning the attacker's input is directly interpreted as some kind of code. So this, again, is the highest impact. Examples here, basically if you had this kind of vulnerable code in your site, an attacker could more or less do anything they wanted. In the least worst case of SQL injection, they could potentially fetch all the user's information, or potentially with this kind of query, get logged in or find information about other users on your site, maybe find out their email address so they could send them a phishing attack through email. There's lots of problems here. Remote code execution is even worse. Right, so basically, if you evaluate something coming in from user input, like the post data, essentially the attacker can just do anything possible in the PHP or Drupal API, and basically they can immediately take over your site. So again, this has the highest impact. This is something you have to be extremely wary about. If you see a Drupal security advisory that mentions something like remote code execution or SQL injection, that's something you need to update as soon as humanly possible. These attacks mean the attacker can almost certainly take over your entire site. They can potentially compromise the underlying server. In the case of Drupal, SQL injection, because of the way Drupal dynamically evaluates things, can often be leveraged into remote code execution also. So we saw that different varieties of that in 2014 when there's an SQL injection vulnerability discovered. Within approximately 6 hours of the security advisory being made, there were automated attacks taking over Drupal sites all over the world. So really, there was almost no time for you to update your site before you might have been compromised. In 2018, we had one that was almost as severe, but was more difficult for people to discover the actual attack vector. So it took about 2 weeks between the announcement and when automated attacks started happening. Then a couple more recent ones that were a little less widespread, vulnerability in FAR file execution and remote code execution via unserialization, and we'll come back to unserialization later. So again, these have been Drupal's most severe vulnerabilities of the past decade have been injections like this. Okay, so those happen only once in a while, but they're really extremely bad. You should audit your custom code, your theme code if you're doing Drupal 7 to make sure that you don't have any of those SQL injections or remote code execution vulnerabilities. Because again, even if it's just your individual site, someone who targets you could take over your entire site. All right, so top 10, OWASP top 10, number 2, broken authentication. This is something that happens much more rarely with Drupal, probably only if you're implementing a custom authentication scheme. So just as kind of best practices here for us in terms of authentication, you should make sure to choose good passwords, especially for administrators. Good meaning especially long, or maybe complex, but long is actually more important. Use two-factor authentication. That means like something like the Google Authenticator or other kinds of second factors to enable login. So there's modules that will help you implement those. Of course, when you store your passwords, you want to make sure you hash them correctly. Drupal handles this, but we've seen cases where contributed modules might have captured the password and stored it in plain text. Of course, protect your session IDs. In particular, you want to use HTTPS and make sure that all your Drupal sites are set up as much as possible to only use HTTPS. So really, there's no excuse not to. This helps you with your Google page ranks, helps you get faster connections with HTTP too. Essentially, all sites should always be on HTTPS now. Okay, so 3, sensitive data exposure. This is a very broad topic. So in terms of the Drupal context, what this means is if you are trying to store sensitive data, like credit card numbers or personal information, you better have a good way that you can at least encrypt them. So it's not easy if someone, let's say, gets access to your database dump to retrieve this information. Better yet, right, it's encrypted except for when it's decrypted for a specific user. That's very difficult to set up correctly. But really, the better thing to do is don't store this kind of sensitive data if you don't have to. Compliance with the PCI, which is for credit cards, or HIPAA for medical information, is really hard, and the fines can be really quite high if you mess it up, or the fallout. So basically, don't do it. Don't store information you don't need, and you basically need to have a good sense of what you're storing. Basically, know your risk level. Even if you implement the perfect encryption scheme, weak keys or poor key management can still expose this data. So encryption is not a cure-all by any means. Really, your operational procedures are still highly critical to make sure that you're actually secure. Again, use HTTPS for all traffic and make sure your passwords are properly hash salted. Again, make sure you're not accidentally storing them somewhere in some custom code in plain text. But even properly stored passwords can be broken if people use weak passwords. So again, you need especially long passwords or two-factor authentication to protect yourself against the leak of your database backups. Okay, so XML external entities. This is a vulnerability that affects systems other than Drupal more often, especially Java or systems that use a lot of XML. However, there have been attacks against PHP web apps using XML entities, and this surprisingly is actually quite high impact and relatively common still. And external entities can be used to expose private content from the server, can conduct network scans, can be used for denial of service attacks, all kinds of things you wouldn't imagine because let's say someone allowed external content to be included in their XML or rendered in their XML. So this affects anywhere that XML is parsed. So that could be if you are using, let's say, SOAP for remote API calls, using SAML for single sign-on, using OPML to consume someone's feed. So any place that XML is being parsed in Drupal, you're potentially vulnerable to this kind of attack. There were XML-based attacks on Drupal through the XML RPC library that you will notice is no longer included in Drupal core. And you really sometimes don't have that much control over whether you're vulnerable. So XML parsers may allow external entities by default. So it may depend on your underlying PHP configuration, what the defaults are. And you need to be aware of what XML parser is being used by any vendor libraries that are consumed by your customer contributed code. So consider the source of any XML you're parsing. Consider whether the user, let's say, through a single sign-on flow, could inject tampered XML into something your site receives and could be parsed. That's where these vulnerabilities tend to crop up. Or again, if you're consuming someone else's feed or someone else's API, of course, they basically have the option to attack you. Okay. OWASP Pop 10 number 5, broken access control. This is kind of obvious, right? Perhaps, but we're going to dive into this a little more often because this is the first one that starts to occur pretty frequently in Drupal contributed code, sometimes even in Drupal core, and I would say very frequently in custom modules. So when you see a security advisory, if the security advisory describes it as access bypass vulnerabilities, that's basically the same thing as broken access control. So an example of such a thing is a custom page callback that displays a node without checking any node access, right? So basically anyone who knows how to navigate to this path might be able to display any content on your system without being logged in or by bypassing any kind of node access or restrictions on unpublished content. Worse, of course, would be if there was an administrative form that allowed anyone on the internet to change some administrative settings on your site. And again, this is surprisingly common, especially in custom code. This is what it might look like in Drupal 7. So we have hook menu here defining a path or a route. And you see the page callback is Drupal get form. And importantly, the access callback is set to true. That means there's no access restriction. Anyone who can access this path can access and submit the form, change the administrative settings. Exact same thing is possible in Drupal 8 and 9. The route looks very similar, right? We have the same kind of path. We're accessing a form. In a route, you would set requirements access true. And again, anyone who can find this path can access and submit the form. Now, this is rarely, having access true is very rarely the thing you want. Sometimes useful because there's additional access controls underneath. But if you see this anywhere in a custom route, you should basically raise a red flag. Okay, so it's very easy to fix this, of course, in Drupal 7. Put an access argument in that is a permission that you want to check. In Drupal 8 or 9, in the requirements section, you specify the same way a permission that needs to be checked in order to access this route. That's it, pretty easy. But again, if you see the permission or the access callback set to true, raise a red flag, ask why. Okay, another common problem in the Drupal context, especially in custom code, is omitting the node access tag when you're doing database queries for something like nodes, or there is less of sort of an entity access system, but again, you may want to do this also for any kind of other entities. There are tags specific to that entity type, right? So when you're doing a database query, you'll see that add tag method with node access basically tells the database query system that it needs to potentially rewrite this query, add in the node access records as a join to the query to make sure that the current user is only accessing things that they have access within the node access system. In Drupal 8 and beyond, a good way to make sure that this happens automatically is not to do direct database queries, but actually to do entity queries. By default, all entity queries add the appropriate access tags to the underlying queries if they're SQL queries. Also, you get that extra layer of abstraction and don't have to worry about whether it's actually a database query or something else. So again, if you see in your code anywhere, custom code, in contributed module code, a database query and is not adding this node access tag, that again is a red flag, something to look for. It's a little harder, right, because it's looking for a negative. You're looking for the missing tag. Okay, so OWASP top 10, number 6, moving on, security misconfiguration. So this is an extremely broad topic. I'll give you a couple examples to think about, but this could cover half the things in the world in terms of possible vulnerabilities. But a few specific ones in terms of Drupal context. Display of PHP error reporting. So especially in production, or you need to disable PHP error reporting. This is important because it's not uncommon for there to be some kind of errors triggered if the user probes, let's say, missing paths, puts in some unexpected URL query parameters, you can get some kind of error, even a PHP notice. If you have this error reporting turned on, the user may get information about the system reported in those error messages, such as the full path to your Drupal files on the server file system. Or, for example, if there's some kind of SQL error, they may be able to see what kind of database server you're using, what version of the database server potentially. These things can help the attacker basically figure out how to further attack your Drupal site or your server. So turn that off. Using Drupal 7, you should disable, or better, remove from the codebase the PHP filter module. That PHP module itself basically is a remote code execution system. So that is something you don't want turned on at your on your Drupal site. Finally, a very common misconfiguration and something you may not be able to avoid with shared hosting is having the PHP files, so your Drupal files, writable by the web server. So write permissions for the web server user pose a real risk because any kind of file upload vulnerability is then potentially translated into a essentially remote code execution vulnerability. If the file server can overwrite, let's say, index.php, or write a new PHP file at the top level of the directory, or things like that. So there's a handbook page on Drupal.org, secure configuration, that you can review and gives you more information about how to correctly secure your site. Permissions is a big issue around secure configuration. So remember at the beginning, principle of least privilege and trust. So be careful with restricted site, potentially site owning permissions, meaning someone with that permission may be able to take over your entire Drupal site. You need to think about which roles on the Drupal site you trust. If you look in the permissions list, you'll see that certain permissions are flagged as essentially dangerous or admin only, right? And basically those permissions, if you give them to a user, there is a risk that user could basically find a way to take control of your entire site. The same is true for text formats. We haven't gotten to the cross-site scripting section yet, but just remember, if you give someone the full HTML text format, that is the same as giving them permission to execute cross-site scripting attacks against you. In general, you don't want to use the user1 account in your daily work because the user1 account has all permissions, or more importantly, bypasses all permissions. In Drupal 89, there's also a way to flag a given role as the admin role. Anyone with this admin role has the same basically bypass of permissions, meaning they can do everything on the site. So if you need basically super admins on your Drupal site, you should give them that administrative role. That way you can see who individually logged in and potentially made changes to your Drupal site rather than having a shared user1 account. That's no longer anything you should be using. You should probably go ahead and block that account or even put in a little custom code to prevent it from being used at all. Also, just a simple best practice, don't name your user1 account admin or something else that people can sort of easily guess and try to brute force the password. Another very common security misconfiguration with Drupal is making it so that private files are not actually private. This is something you need to basically fix at the server level if at all possible by moving the private files directory outside of your document root, which avoids any possibility of direct downloads. So you see here we have the document root that has index.php, and we have as at the same level a separate directory for private files. That way the web server, if it's correctly configured, can never directly serve files from the private directory. Those can only be served through PHP, through Drupal, applying the correct access controls. This is something really important to check. Very common that people use a private files directory under their public files, and they may be relying on, let's say, htaccess files to protect that directory, but if the web server doesn't actually respect htaccess files and the attacker can figure out the file path to the private files directory under the public directory and just download all your private files. Okay, so another common security misconfiguration is being at risk of having PHP files be executed other than the Drupal index.php. So Drupal uses a front controller pattern where everything goes through index.php normally. So that means you don't have to allow any other PHP file to be executed in the Drupal document root. In particular, you can disallow execution of PHP files in subfolders, and Drupal 8 and beyond come with a default htaccess rule that tries to block this. But this is something you can implement basically for yourself, or if you're using a different web server. Preventing PHP execution especially in the files directory, because that's the sort of most common place you might have a file upload vulnerability, allowing someone to bypass the file extension restrictions, or potentially the web servers interpreting a file as PHP that you didn't expect, let's say a PHP 5 extension or a PHP 7 extension. Basically, you can turn off, as I said, execution of PHP files or limit execution of PHP files to only index.php or only things at the top level of your document root. Okay, so we could go on all day about security misconfiguration, but let's move on to OWASP top 10 number 7, which is cross-site scripting. We're going to spend some time on this because this is historically the most common security vulnerability seen in Drupal code. And cross-site scripting fundamentally is when attackers can inject JavaScript tags somewhere into the page or page content, or as a JavaScript file included in the page. So the principle basically for preventing this is that all user input must be sanitized before you output it. Cross-site scripting is not quite as severe as something like injection, OWASP top 10 number 1, because some kind of interaction is required, right? So even if there was an automated cross-site scripting attack, some way that the attacker could put this kind of attack onto your website to attack you, you would still have to visit your website as a logged-in administrative user in order for the attack to be successful. That still is not necessarily that difficult, especially if someone's attacking you specifically, because they can find a way to redirect you, send you a shortened link, for example, bit.ly link or something that would redirect you to the page with a cross-site scripting attack, and you might naively follow the link in an email from a blog post somewhere else where they had sort of laid the trap for you. So there's two kinds of cross-site scripting to be aware of. The first is reflected cross-site scripting. We sort of have an example here where, let's say this is somewhere in a Drupal 7 theme, where you're printing something directly from the query string. The query string is user input. Any user in the browser can change the query string at any time. And the user could basically construct a query string, and then, as I said, potentially send it to you as a link or send it to you as an obfuscated link as a redirect and get you to go there. Right, and so that cross-site scripting, the script tags could be in the get parameter in the query string, be printed to the page, and potentially executed in the browser. What you'll see commonly for cross-site scripting as a penetration test is to try putting script tags with an alert into different fields, into different form fields, into different query string parameters, into different form variables. So that's a great something you can do again. And here's another example where that might be useful test. Persistent cross-site scripting is where JavaScript is stored in the database. So imagine you put that sort of penetration test of script tags into a node title. You see here this code is vulnerable because the node title is being put directly into essentially the output of a table row. This is a Drupal 7 example. In Drupal 7, when you basically theme a table, it turns out that the content of the rows is not escaped. You might think it was because this is a nice theme function that automatically prints things, but in fact, the raw content of the node title would be printed in this case, and if you allowed users to set the node titles, they could put a script tag in the node title, and when you as administrator visited this page and the script executed, their attack would be successful. So again, preventing cross-site scripting in this Drupal 7 example, you need to call checkplain on the node title before it's basically sent to the theme function. That's one of the tricky parts about Drupal 7 and before, that you had to know a lot about the API, know which text was going to be printed basically as plain text and which was going to be automatically escaped, let's say, from the L function that automatically would escape the text in there. So we, again, have handbook pages on Drupal.org to help you learn about handling text securely. So one of the things you need to keep in mind, and the reason why this is a problem, this has been historically a common vulnerability in Drupal, is that cross-site scripting is really dangerous. Some people assume that that penetration test I showed you with the alert is the actual attack, that at worst your site will be defaced by pop-ups. But in fact, cross-site scripting is much, much worse than that. If you, as an administrator, get attacked through a cross-site scripting attack, if the attacker was clever, they can put in a script that will do basically anything that you, as the logged-in administrator, can do on your site. That means creating new user accounts, changing the passwords on other users' accounts, enabling or disabling modules, changing filter formats, anything at all that you as an administrator can do. The cross-site scripting attack, as JavaScript running in your browser, could also do. So here's an example article that talks a little bit about that in more detail. But just be aware of that. This is cross-site scripting is not a defacement. Cross-site scripting, if executed against you, means the attacker essentially can and will take over your entire site. So again, how do we prevent this? We filter data on output. Any user input must be filtered when it's printed to the screen or output through a theme function. Golden rule in this is that we want to store exactly what the user typed. So thinking about form input, user types in a blog post, for whatever reason, that content might include some HTML tags or script tags even because they're writing a blog post about how to write JavaScript. We want to store that content exactly. We don't want to filter it out because when the user goes back to edit their blog post, they'd be really upset if they lost all their code examples about JavaScript. So this means conversions are performed when the content is output, not when they're saved to the database. User's input is always saved exactly. This is by design in Drupal. This is not a bug. This is by design. When we output the text, we have to handle it safely. We need to be aware of what is user input. So here's kind of a hierarchy of types of content and examples with the Drupal 7 and before functions that you might use to sanitize them. So first, if you have something that's a URL, there's a specific function for filtering that. Plain text that shouldn't have any HTML in it, you use check plain. Rich text, you would use check markup with a specified text format. Something that might allow basically all tags except for script tags, you can use this filter XSS function. And in basically almost no cases would you want to print directly user input without filtering in some way. Basically, the only things that should be printed are trusted text like fixed translatable markup, like a string that should be localized to different languages. There's basically similar hierarchy in Drupal 8. We have a URL helper class method that will strip dangerous protocols out of URLs. This is something new in Drupal 8. If you're putting a URL in a typically a localized text, like the T function equivalent in Drupal 8, there's a new placeholder, not just the @ and % placeholders, but also the colon placeholder that will apply this to URLs. In Drupal 8, typically all of your rendered text is going to go through the render system. In your render elements, you can always use these elements or keys in the render element, markup or plain text. So anything in plain text is escaped, so all HTML tags are escaped. Anything in a markup is filtered for cross-site scripting if it's a string. Actually rendering raw text requires wrapping the raw text in a markup object, or for example, in the Drupal 8 equivalent of the T function, those are flagged as not being escaped. You don't want to do that. You never ever want to wrap user input in a markup object or concatenate user input into something that is presented to the Drupal system as what should be safe text that's going to be localized. So again, Drupal tries to mitigate cross-site scripting for us, but you as a developer need to be aware of the API, where essentially the loopholes are in the API, especially in Drupal 7 and before. But Drupal core does help us in a few ways. So we try to flag session cookies so they can't be pulled out by JavaScript. That reduces the impact of cross-site scripting in as much as the attacker can't get your current active admin session. Password changes require the current password. So this helps protect non-administrative users, but as I said, administrative users can change other users' passwords without knowing their own password. Text formats, again, we talked about the danger of the full HTML format. So you need to be certain that you understand which text formats allow which HTML tags to be passed through, or if they allow all tags to be passed through, and assign them appropriately to different roles on your sites. And then the most important thing that we have had happen is auto-escaping in Drupal 8 and 9. So by default, the Twig templating engine in Drupal 8 and beyond will automatically escape any text that's printed if it wasn't already escaped. Another advantage you have in Drupal 8 and beyond is the ability to apply a content security policy. This is much more difficult to do in Drupal 7 before because of the way that Drupal settings and things like that are implemented. Content security policy is a W3C standard. If you set up your Drupal site correctly, you can tell the browser that no inline JavaScript should be executed, and you can have a waitlist of third-party domains that are allowed to be used to include JavaScript in the page. The ability to block all inline JavaScript is a feature I help work on for Drupal 8 and beyond, where we move things like Drupal settings and every other kind of inline script tag in Drupal 8 to script includes. That way, you can implement a content security policy on your site, blocking all inline script. That means things like the no title attack we saw before, where the user's text was printed to the page and included script tags. That cross-scripting attack would actually be blocked if the browser correctly respects this content security policy. So this is not something implemented by default. I'll come back to a module that might help you implement this. But none of these things are perfect. Browsers can not implement these policies correctly, even if you have it on your site. There are, always ways around these. There have been historically character encoding issues, all kinds of ways to bypass the protections that browsers try to provide you. So most important thing to remember is still make sure you rigorously escape any kind of user input, that you don't trust anything that's user input. User input, again, includes things that might be saved in the database, like the no title, might be coming from the query string, might even be coming from cookies that the user sends, because those can be tampered, can be coming in form data, in the post array. All those things need to be treated as untrusted user input that may be used to execute an attack on you and your Drupal site. Okay, so now we're kind of in the home stretch, insecure deserialization. This is still a pretty common attack across all kinds of web applications. Unserialization in PHP can be exploited by magic methods like destruct to actually then execute potentially arbitrary code or SQL queries, or to do things like deleting files on the file system that might break your Drupal site completely. So we did see a recent Security Core advisory where serialized strings could be parsed as part of API calls. This was sort of a legacy of things that were originally intended to work with the form API being converted and also accessible through the REST API. As a developer, you need to be aware of this and never use the PHP serialized format for data that you might store in cookies, form data, etc. Because remember, those are user input. If you're trusting serialized content coming from cookies, form data, etc., attackers could tamper them. Attackers and users are really the same, and execute this kind of deserialization attack against your website. If you need to put serialized data in one of these contexts, use a safe format like JSON. Okay, OWASP top 10, number 9, and something that's extremely widespread, and again, this is something you need to pay attention to. You need to have a process for this. You need to not put your Drupal site on the internet and forget about it. You need to be updating your Drupal code basically as often as every week. So once components are known that have vulnerability, these are widespread attack vectors. People will automate those attacks. So you need to be updating your server software, all your software regularly. Monitor different kinds of security mailing lists and RSS feeds. Potentially want to enable Drupal's update status module. Ask for emails to be sent to you from a Drupal site if you need an update. So if you have that turned on, for example, Drupal knows about new versions of Drupal that are available. Look on Drupal.org at the list of security advisories for the details. And disable components in general, or don't install the components that are not used. So if you have, a module on your Drupal site enabled, but you're not using that functionality, you've increased the possibilities for people to attack you if a security vulnerability is found in that module. So turn off the modules. Audit the list of modules enabled. Maybe find that one line of custom code you can write instead of enabling a large module that might include some security vulnerability that allow attackers to take over your site. If you turn on that update manager module in Drupal 8, for example, you can go to this path, put in your email address, and so that you don't get too much noise, you can flag it to only email you about security updates. I recommend you do this, especially if you have individual Drupal sites you're maintaining. You should do this for all of them. In terms of outdated components, remember that Drupal 8 and Drupal 9 will be end of life before too long, meaning they're not getting more security updates. The Drupal 7 end of life was recently announced to be extended to November 2022. Drupal 8 will be end of life in November 2021. So you should have a plan, be thinking already about how you're going to get off these. And again, remember, this really, keeping your Drupal site up to date, keeping your server software up to date, is something that you need to do regularly. Some of the biggest security exploits across the web recently have been because of outdated web application components. You remember that a big Equifax vulnerability, they had an outdated component for months that was on their web application, and someone basically just went around and looked for the signature of that outdated component and was able to breach their entire system and get millions of people's records. Okay, so OWASP top 10, number 10, insufficient logging and monitoring. So what is happening to your Drupal site right now? Do you know? Do you know if people are trying to log in, brute force logins, unusual requests happening? If your Drupal logs or system logs were deleted, do you have a central copy? Do you have a way to figure out when these attacks were happening in the past? Again, recent profile attacks have been going on actually for months, like the Sony attack was apparently going on for months before it was detected. So having logging, having copies in some central place of your logs can be really important for finding out when these things started, basically at what point your data might have been compromised. Remember the integrity component of CIA. So once someone has compromised your system, you may no longer be able to trust the integrity of the data after that date. So, of course, it's not enough to be logging your data. You need to actually read or search your log, either manually or in an automated way. And you need to have some kind of central, potentially, or more permanent log storage, maybe outside the Drupal database, so an attacker can't delete or modify log entries in the past, or delete or modify log entries on your single server. If they compromise the whole server, maybe they get root on the server, they could just go ahead and delete all the logs. So you'll have no idea when this attack started, when your data might have been, the data integrity might have been compromised. Okay, so that was the top 10. I just wanted to briefly stop back. That's something that was removed from the top 10 in 2017 from OWASP. Top 10, cross-site request forgery. This is still problematic, but it has become less and less of an issue because frameworks like Drupal help protect you. Basically, the summary is that cross-site request forgery can happen anytime a write operation happens, and it can be happening through a user just visiting a link and not by, let's say, submitting something like a form that includes a form API token, or by, if they didn't use a link that includes a secret token in the URL. The way to avoid this is to always use the form API when you're changing or deleting data, or in the rare case that it's appropriate to use a link. Drupal 8 will help you automate generating and confirming those tokens in a link. JavaScript can execute cross-site request forgery post attacks, or you might accidentally yourself submit a form on a malicious website that would post to your website. There's also a new same-site attribute on cookies that provides sort of a new protection by default, but again, not all browsers may be implementing this, and we have some handbook pages on this. Again, revisiting the pattern here. The pattern is that user data in the URL, the request content in the database, cannot be trusted. Any user may be an attacker. Attackers use browser features to perform these attacks, and very commonly, attackers use known vulnerabilities to automate these attacks as a mass hijack, so you should not believe that you are special. If your Drupal site, your server has outdated software, attackers will simply mass automate those attacks. They will probe every Drupal site or every website on the internet, every server on the internet, if they can find a way to exploit this vulnerability, they will. So again, you're not special. You need to keep your software up to date. And these best practices and security, it's not a checkbox. Again, it's a workflow, it's a process, it's a mindset, something you have to come back to every day, every sprint, every code release. You need to be thinking about the security of your code, the security of your server. There's a great security best practices guide you can download here from this link. I recommend you look at that as a starting point. Also, to think about how to have a best practices. And again, remember, you need this to be part of your workflow. You need to budget time for it on an ongoing basis as part of your process. You also need to be prepared for an attack. Is your code in version control? Shocking, but lots of people still don't have their code in Git or SVN, so they wouldn't know if someone had changed the code. How often do you make full backups? Do you have separate logins for each admin? As I said, you don't want to use user one account for daily administrative access. If you're responsible for the server software, do you keep it up to date every time there's new software updates? Do you have a way to access your Drupal site like SSH and Drush if someone, let's say, changed your administrative password? Do you know where to find the Drupal logs, the web server logs, syslogs, so you could analyze them if you needed to? And again, you have copies of them that are not on your one server and therefore are safe from being modified by an attacker. A big part of this is that your hosting matters. And if you are not providing hosting as a full-time service, if you're not an expert in system administration, you should really think about paying someone else who is an expert to host your website. Obviously, you have to vet them. You should be extremely cautious about using any kind of shared hosting. Shared hosting often has thousands of websites on one server. Typically this is like a cPanel system. It's great, it's cheap. It's only $10 a month, maybe less. But oftentimes the web server can write the code. As I said, this is a common security misconfiguration, but it's the way they configure it in order to scale out to having thousands of websites on one server. Oftentimes these systems may not be set up in a secure way, so if a different website on that same server is compromised, let's say their web application might be able to write to your code. So you and your Drupal site might be compromised through no fault of your own, but just because you're on shared hosting and some other web application is compromised on that same site. This can also be true if you're in an organization that hosts multiple web applications on the same server without good separation between them. If you're in that kind of situation, you should know who else or what other web applications are on the same server and think about how you can maybe get isolated from them. If you're attacked, you need to basically have a plan to recover. Figure out when you were compromised, what happened, restore from backup, update your code, update your server software, change all your passwords and keys, audit your code to figure out where that vulnerability happened, especially in custom modules, and then look through your logs to try to figure out when and how that vulnerability happened. So maybe if you didn't find the vulnerability in your initial scan, those log messages would point you to the vulnerability. Last, just mention the Drupal security team. If you want to find out more about the Drupal security team, there's a handbook page here. Important take-home is the goal and purpose of the Drupal security team is to coordinate responsible disclosure. So anyone can create a private security issue at security.drupal.org. This is the way we coordinate people reporting security vulnerabilities in Drupal core or Drupal modules. The Drupal security team coordinates security releases with maintainers of Drupal core or contributor modules. That's basically the goal and purpose of the security team, is to keep those issues private until there's a fix available, and then coordinate the security advisory to make the vulnerability, the fact that there's a vulnerability and the fix public at the same time. So the security team also defines security policies, like which permissions need to be flagged. Also defines the risk levels that are shown in the security advisories, but does not audit code. So if you see a module saying it's covered by the Drupal security team, what that means is that we will help coordinate a report of a security vulnerability in private. We do not audit that module to make sure it is actually secure. Modules that are not covered by the Drupal security team, any security vulnerabilities will immediately be reported in public, which means any attackers can see that vulnerability and use it potentially to try to exploit Drupal sites using that module. Again, you can stay up to date. There's in your Drupal.org user profile this way to add security notices newsletter, so you can automatically be informed every time there's a security advisory or other announcement from the Drupal security team. Okay, so to wrap up, here's a list of some resources you might want to look at. In particular, one module I'll mention is the Drupal Security Kit module, which can help you implement a content security policy on your Drupal site, which is not implemented in Drupal core by default. Again, look at security advisories. In this talk, the title of this talk comes from a book called Cracking Drupal by Greg Nattison. It's a little bit old now, based on Drupal 6, but still has a lot of useful information, kind of principles about vulnerabilities in Drupal and other web applications. Okay, so that's it. Thank you for listening, and I hope that this was informative.